Hello everyone, welcome to the online lecture series of the course EE204 Digital Electronics and Logic Design. Module 4 Sequential Circuits and Asynchronous Counters. Today we are going to study about the shift registers. In the last class we have already seen the first two shift registers, serial in, serial out, SIPO shift register and serial in, parallel out, SIPO shift register. The next one is parallel in, parallel out, PIPO shift register. This is just an extension of a single flip-flop. Here, for each bit to be stored in the shift register, you need to have that much number of flip-flop. Which means if you have an n-bit data to be stored, you need to have n number of flip-flops. All the D inputs of the flip-flops are the input data bits and all the outputs of the flip-flop are the output data bits. In order to complete the operation of a PIPO shift register, only one clock pulse is required. Since all the flip-flops are provided with clock signal simultaneously and the data is provided parallelly for one clock pulse, the data will be parallelly inputted as well as data will be obtained as the corresponding outputs of each of the flip-flops. This is the logic circuit diagram of a parallel in, parallel out PIPO shift register. You can see the connections are simple. For each flip-flop you have to provide the same clock. The input of each flip-flop will be corresponding one bit of the input data. Similarly, the output of each flip-flop will be the one bit of the parallel output data. Now let's have a live simulation to understand further about the PIPO shift register. So let's check the asynchronous inputs first. Making the preset to 0 will set all the flip-flops and the clear to 0 will reset all the flip-flops. Now you have to provide your input data. Now set the input data to 1010 and a clock pulse is given. Which will set the output of each of the flip-flop to the required value. So within one clock pulse the input data is stored into the flip-flop and we are obtaining the parallel output as the same input data 1010. Now let us have the input output table of a PIPO shift register. If you give the input as 1001, in the first clock pulse itself your output will become 1001. Now if you want to give another input data during the second clock pulse, you can give it as say 1010 and correspondingly the output will become 1010. So this completes the operation of a parallel input parallel output shift register. Next one is a parallel in serial out PISO shift register. PISO shift register is similar to the working of a PIPO register in the case of inputting the data, but outputting the data will be different in the case of a PIPO register. The PIPO register output the data serially, which means we'll be obtaining only one bit at a time. In order to input the data, one bit is required to input all the bits parallelly to the shift register. And in order to shift the data, you require corresponding number of clock pulses. If you are having n bit data, you require n number of clock pulses. This is a simple logic circuit diagram of a PISO shift register. Here you have to make sure that the input data after first clock pulse will remain as zeros, especially the input data bits I2, I1 and I0 must remain as 0. If it is not maintained as 0, your output will be obtaining some other value which will not be same as the input data. So in order to prevent this change in the output data from input data, we can use combinational logic circuit to add up the additional features. So this is the circuit diagram which will be taking care of the loading and the shifting of a PISO shift register. Here we have introduced a mode, that is the load or shift mode, which will operate one at a time. Either you can load data into the shift register or you can shift data from the shift register. So the loading operation, as it is done parallelly, you need to do only for one clock cycle, and the shifting operation you have to do for the next n-1 number of clock cycle, because you will obtain the first input data I0 bit as the output in the first clock pulse itself. So the remaining I1, I2, I3 data you have to provide 3 more clock pulses, which you have to provide in the shift mode. So in order to understand the working of a PISO shift register, let's have a live simulation. The circuit diagram shows a 4-bit parallel input serial output shift register. So as usual, check the output of flip-flop using the asynchronous inputs. Making the preset to 0 will make the output 1, and making the clear input to 0 will make the output 0. Now let's start the PISO operation. We are going to input a data 1001. So upon setting the input data, you have to do the operation in load mode. The load mode will write the data into the flip-flop. So make it as 0 and apply a clock pulse. On applying the clock pulse, you can obtain the last bit I0 bit as the first output bit. Now the data has been already inputted into the flip-flop register. Now the data has been already loaded into the shift register. Now you have to do only the shifting operation. So in order to do the shifting operation, change the mode to shifting mode, that is 1. Now you have to provide the remaining 3 clock pulses to obtain the remaining 3 input bits. So for the first clock pulse, your output will become 0, and for the next clock pulse also your output will become 0. Next clock pulse also your output will become 0, and the last clock pulse will give you the remaining last bit, which is 1. Let's have the input output table of a PISO shift register. In the first clock pulse, we are providing the input parallelly. So I3, I2, I1, I0 is having your 4 bits, that is the 1001. And you will be obtaining the last bit I0 as the output itself. And for the remaining 3 clock pulse, we are making the input bits to 0, because once we have loaded data into the flip-flop, then for the remaining n-1 number of clock pulse, we have to make the input as 0. If the input is non-zero, your data will be changed accordingly, or it will be different from the data inputted. So during the second and third clock pulse, the second and third bits 0 will be obtained, and during the fourth clock pulse, the last bit 1 will be obtained as the output. This completes the working of a PISO shift register.